Here we are in section 1.7 with solutions to numbers 37 through 45. A couple of things that we're going to remember that I'm going to write over here is number one is that when we are adding and subtracting, so when we're adding on these, I don't think there are any subtraction problems, we need like things. That has been a basis since we started adding, that we need like things. So right here, the fact that these exponents are different or that these are different means we're going to have to change them. So if we change them, if we move the decimal left, that means we have to go up, left, up. That's the basic way of changing a scientific notation to look a little bit different. And finally, if we multiply, we don't have to have like things, and that's very important. And then if you multiply, then that means you're adding those exponents or zeros that are on there. So we're going to refer to those throughout these problems. Let's see if we can do them now. Number 37. 5.3 times 10 to the 9th plus 6.9 times 10 to the 10th power. These need to be the same in order for us to add them, so I am going to do that. I'm going to go left with this decimal and go up here. Let's highlight that again, left, up. So I now have the problem 0.53 times 10 to the 10th and 6.9 times 10 to the 10th. Now when we add them, this decimal in both of them are exactly 10 places over here, that direction, 10 places. So the decimals are truly lined up now. 3, 5 plus 9 is 14, 1 plus 6 is 7. So 7.43 times 10 to the 10th, since the decimals stay up. And when we add like things, the things don't change. If we had 0.53 apples, 6.9 apples, we add them, we'd get 7.3 apples. Same exact thing there. Alrighty, the next one, number 38. 8.015 times 10 to the 7th plus 3.14 times 10 to the 5th. Yeah, these are not like things, so I'm going to have to go up with this guy. So it'll become a 7. That means I have to go 1, 2 to the left. Left, up. So my problem now is 8.015 times 10 to the 7th plus 0.0314 times 10 to the 5 plus 2, 7. That's why I did that. So now we have 4, 6, 4, 0, 8. So those just all add up, all times 10 to the 7th. And we now have a correct answer. Okay, number 39. 5.30 times 10 to the 9th times 6.9 times 10 to the 10th. Notice that this is the exact same problem as number 37 over here, except that we are not adding. We are timesing right there. So let's do the normal multiplication. We do not have to have these things be alike in order to multiply them. 9 times 3 is 7, carry the 2. 9 times 5 is 45, plus 2 is 47. Now change colors here. 6 times 3, oh, don't forget that 0. 6 times 3 is 18. 6 times 5 is 30, plus 1 is 31. So we now have 7, 5, carry the 1, and that's 6, 3, and we have 2 decimal places. So 36.57 times 10 to the, now let's not forget this guy right here. When we multiply, we add the exponents. So this becomes 19. 36.57 times 10 to the 19th. We are almost done with the problem. This is not incorrect scientific notation. Remember, scientific notation needs the decimal to be right there, which means we're going to move it left. And look at that. Oh, hey, look at us use that again. Left means this has to go up. So the answer is going to be 3.657 times 10 to the 20th power. Number 40. 9.54 times 10 to the negative 5 plus 7 times 10 to the negative 3. Now, we have to move them so that they're the same. So we got to move one of them up to get to the other one. If you'll notice, the 5 needs to go up 2 in order to become a negative 3. Now the 3, if you move it up, becomes negative 2, negative 1. So yeah, the smaller one is actually this guy. So if we're going up, we have to go left 2. So our actual problem is 0.0954 times 10 to the negative 3. Okay, so that's moving it left and up to make the same number, but with a different exponent, plus 7. Here's the decimal lining up right there, times 10 to the negative 3. Gives us 7.0954 times 10 to the negative 3. Oh, that was kind of a tricky one. Number 41. 8.01 times 10 to the 7th times 3.1 times 10 to the 5th. If we multiply these, we don't need to have the same thing, same exponent. So 1 times 1 is 1, 0, 8. Good. Now put a 0 down there. 3 times 1 is 3. 3 times 0 is 0. 3 times 8 is 24. So we have 24831. Now, where's my decimal place? We have 1, 2, 3 decimal places. 1, 2, 3. That's just our normal multiplication. Now, times 10 to the what? What's our rule with multiplication? In multiplication, these guys add. So we have 12. We are not yet done, however. This is not inappropriate scientific notation. This has to be moved this way. And this has to go plus 1. Left, up. So that now it's official scientific notation. 4831 times 10 to the 13th power. There we go. Next one, 42. 9.54 times 10 to the negative 5 times 7 times 10 to the negative 3. Look at that. It's just like number 40, except now we're timesing them, which means we don't have to do like things. We don't have to do this, this guy right here, because we don't have to have like things when we times. So let's multiply them. 7 times 4 is 8. Carry the 2. 7 times 5 is 35. Plus the 2 is 37. Carry that 3. 7 times 9 is 63. Plus 3 is 66. And there are 2 total decimal places over here. So we have 66.78 times 10 to the, now we're multiplying, and it tells us what to do here. We add those exponents. So that's a negative 8. That's negative 5 plus a negative 3. That's a negative 8. We are not done. We have to move this decimal so it's in proper scientific notation. We have to have only one digit on the left of the decimal, so we've got to move it right over there. So we have 6.678 times 10 to the, now if we moved it left, we go up 1, and we get 10 to the negative 8 plus 1 is negative 7. So there we have the answer to number 42. Number 43, 7.24 times 10 to the negative 7 plus 7.1 times 10 to the negative 8. These are not alike, so we can't do the adding right here because we can only add and subtract like things. So we need to change it. We can change that one or that one. So if we take this and add 1 to the negative 8, that'll make it a negative 7. So we're going up, so we can move this to the left. So the actual problem that we have is 7.24 times 10 to the negative 7 plus 0.71 times 10 to the negative 8 plus 1 is negative 7. So that becomes a 5. 2 and 7 is a 9 and 7. 7.95 times 10 to the negative 7, and we are now in official scientific notation. Number 44. 4.05 times 10 to the 7th times 7.19 times 10 to the negative 5th. Here we're going to times the 9 through just like normal. This is just a normal decimal problem, though a little large. 9 times 5 is 5. Carry the 4. That's a 45. 9 times 0 is 0 plus 4 is 4. 9 times 4 is 36. Put a 0 down for the next one. Let's do this in a different color. 1 times 5 is 5. 1 times 0 is 0. 1 times 4 is 4. And now the final one, if we take this 7, let's put 2 zeros there. 7 times 5 is 35. 7 times 0 is 0, plus 3 is 3. 7 times 4 is 28. So when we add those guys up, we get 5. 4 plus 5 is 9. 6 plus 5 is 11. And we now have 3 plus 4 plus 3 plus 1 is 11 and 29. Now, where's our decimal place? 1, 2, 3, 4. So we've got to go 4 decimal places. 1, 2, 3, 4. 29.1195 times 10 to the, and remember what we have here, multiplication, add exponents. So this guy comes down here, negative 5 plus a 7, that's a positive 2. So we need to put this now in official scientific notation, and that means we can only have one digit right there. So we've got to move this guy to the left, up. So we get 2.91195 times 10 to the 3rd power. That's the final result. Big problem there. Number 45. 2.7 times 10 to the negative 9 times 5 times 10 to the negative 13th power. Again, they do not need to be the same for multiplication. So we take 5 times 7, that's 35. 5 times 2 is 10, plus 3 is 13. One decimal place is 13.5 times 10 to the, let's add up those exponents. Negative 9 and negative 13 adds up to a negative 22. This is not in scientific notation. We have to move this guy over one place to get it into proper scientific notation. 1.35 times 10 to the left, up. That's 10 to the negative 21st power. And there we have our first assignment with scientific notation. Good.